I just want to quickly explain the idea of planes when we're dealing with three-dimensional shapes and we're dealing with three axes. So we have an X, a Y axis, and a Z axis. Okay? And I just want you to understand what happens here and just to visualize that we're now, when we draw equations that have three variables, we are no longer dealing with straight lines, because when we graph, we'll have what's called an XY plane. There's the XY plane, which is what we normally deal with only. But now we also have an XZ plane and a YZ plane. So now we have three planes basically that we're dealing with when we graph. And because it's planes, then basically everything that we're doing graphically is about planes, not straight lines with three variables. Now, if I plot an equation that has three variables, what I do is I create a plane, not a straight line, but a plane that has a special orientation, just like a straight line has a position and an orientation. A plane that that is drawn from three dimensions, from three variables, creates a plane. And if we change that plane, I mean, we can change the values in front of the variables. So change the variable in front of X or Y or Z. What we do is we just move the position of the plane around. And if we add an equation to this mix, and let's just change it a bit. Basically, these planes interact with each other and cut through each other in various positions. And how they interact with each other and how they cut and intersect each other is what we have to determine. And we're going to be determining it with basically three equations. So three variables and three equations, and how they interact with each other and how they intersect with each other. And although we don't use a graphing program to do this with, we do it mostly algebraically, which is the difficult part of this, is being able to visualize what we're talking about, but also being able to deal with it and think of it in graphical sense. So it's a bit tricky.